So hello guys, today we are going to discuss this problem, total cost to hire k workers. So the only tricky part is to understand the problem, then it becomes pretty easy to solve it. So we are given an array and we are given two values, that is k and the candidates. So we have to run k sessions and hire exactly one worker per session. That means we have to hire k workers, and in each hiring session choose the worker with lowest cost, either first candidate worker or last candidate worker. So we have to, in every hiring session, we have to choose the lowest cost worker either from first candidate or from the last candidate. So for example, in this problem, in this question, the cost is this, candidate is 2, and let's suppose k is 2. So in the first session, since two candidates are there, we'll choose first two worker cost and we'll choose last two worker cost, for example here. And then we'll choose the lowest worker cost from these two. So lowest worker cost is 1. So the first worker chosen is 1. Now 1 is removed from it and the array becomes this 322 32772. Now again in the second hiring session we have to choose the lowest cost worker. So in this case it will become 2 here, because out of 3 2 and 7 2, 2 is minimum, but the lower index worker is chosen. So it's given here in the second hiring session we'll choose first worker because they have small same cost as fourth worker, but it has the smaller index. So in case of a same, we'll choose a smaller index worker. Right. So let's take this example. Okay, so we have uh, these many workers. We have to choose three workers, and the candidate window or candidate set is 4. So when the candidate set is 4 from first, we'll choose these four elements, 1, 2, 3, and 4. And from last, 1, 2, 3, and 4, we'll choose these four elements, right? So from these two candidate sets, we'll in the first hiring session, we'll choose this worker, which is of cost 2, because in the first window, this one, the minimum cost is 2, and in the last window, from last, minimum cost is also 2, but we'll choose this because this is a smaller index as given in the question. So this is removed. Now our array becomes something like 17, 12, 10, 7, 2, 11, 20, and 8, right? Now in our second hiring session, we'll have a window of these four elements and these four elements, right? So in these, this four candidates and these are the four candidates. The minimum is 2. So we'll take this and we'll add 2 again here, right? So now 2 is removed and our array becomes 17, 12, 10, 7, 11, 20, and 8. So we need to choose four candidates from beginning now. So we'll have 1, 2, 3, 4, and we need to choose four candidates from end now, right? So we can see that the window overlaps, right? Since we are sliding the window overlaps. So in this case, we can choose from entire array, whichever is the minimum cost element. If two same cost element occurs, the lower index will be chosen. So here the minimum cost element is 7. So we'll choose it and it will add up and the answer becomes 11. So this is the basic question understanding. So now how we are going to approach this? Let me again uh, take up some bigger array, 1, 2, 4, 3, something, some random arrays, right? Some random array. Let me take something like this, right? Right, and we have we need to choose five, let's suppose four workers, and candidate window is 3. So in the first hiring session, we'll go ahead and take this window, right? And from last, we'll have this window, right? So in the code, we will be taking this as a min heap of size 3, the size of candidate 3. So this will be a min heap. This will be a min heap, right? So in the first hiring session, we have one here. So we removed it and we increased the size of the min heap. So we slide our window to this. So this becomes our new window now. So now in this case, 2, 2, 3 and 12, 1, 2, we see what is the minimum element. So 1 is the minimum element. So earlier it was 1. In the second session, we got 1. And then again, we'll slide our window and window will slide to here, right? So 1 will not be there. 9, 12 and 2, 3 elements. So now in 9, 12, 2 and 2, 2, 3, which is the smaller, 2 is smaller. So we'll add up 2 here. And since this window size becomes 2, we'll again slide it and our window becomes this 2, 3, 4. Now in 2, 3, 4 and 9, 12, 2, what is the smaller? 2 is smaller and the lower index. So we'll again add 2, right? And we'll again slide the window. So our window becomes this now. But since we already have the 4 hiring sessions, we can just conclude and return this answer. So this is the approach we are going to take. Let's see the code now. Okay, this, let me remove this. This is not required. Pair is also not required. Okay, so we have taken a min heap. Um, Min heap data structure will always have, or the min priority queue will always have a smallest element at the top. So we have a left pointer. Let me bring it here and control N and try to walk with the code. So let us think that we have 1, 2, 3, 4, 6, 7, 8, 12, 1, 2, and 3, something like this, right? And we have k is equal to 4 and candidate is equal to 4. Okay. So now what we'll have, um, so our left pointer, okay, our left pointer will be here. This is our left pointer and our right pointer will be here. Right pointer, okay. Then we are going in a while loop only till the k elements. Then what we are checking that if left queue is the priority queue, size is smaller than the candidates. Oh, I missed, lost the candidates. So candidates were 4 and k was 4. So at present the left queue size is 0. So and the left pointer is smaller than the right pointer. Yes. So we'll make this as our left queue. So this is our left queue. Then we check that if right queue size is smaller than the candidates because right queue is 0 and right pointer is greater than the left pointer. Yes. Now, but now see here, the left pointer will come here. This is our left pointer, right? And 4 elements in the right queue. So this is, let me remove, and the right pointer will come here. And this is the right queue. And let me remove it, right? So now what we are doing here, we are checking the minimum cost in left. So minimum cost in these 4 elements is 1, right? And minimum cost in right, this is also 1. So if we have minimum cost in left is equal to minimum cost in right, then minimum cost in left is taken and left queue is popped out, right? So we have taken 1 and we have added to the sum 1, right? And we gone into the while loop again. So now the left queue size is smaller than the candidate because left queue size is 3, the candidate is 4, and left pointer is smaller than the right pointer. Yes. So we will increment our left queue. So left queue will be 2, 4, and 6, and our left pointer and right pointer will point to the same element. That is it. Now we'll see that if right queue size is smaller than candidate, no, because right queue size is equal. So we'll not go in this loop. We'll check the minimum cost. So minimum cost in left is 2, minimum cost in right is 1. So we'll add 1 and we'll remove this from here. Now again we'll come back and we'll see that left queue size is smaller than the candidate. No, it is not. But right queue size is smaller than the candidate. So we'll move our right queue to here. So this becomes our right queue and this is our left queue. But the point here is our right pointer will be on 7 and our left pointer will be on 8, right? Because we can see here we are doing right pointer minus minus. So now in the next step, we are not going to add anything in the queues because these conditions, that is left pointer must be smaller than equal to right pointer. No, it is not. It crosses, and right pointer greater than equal to left pointer. This also is not true. So now we are just going to find the smaller elements in the queues and we are going to push or add into the sum. So this is the code, and the time complexity for this approach will be log n, because in rebalancing a balanced binary tree, which is a min heap, it takes only log n time. Thanks a lot. Have a good day. Bye.